Let's talk today about a very famous formula called the quadratic formula. The quadratic formula is a method that can be used to solve solutions to any quadratic equation in standard form. When you read the quadratic formula, it's important to know that we're not going to say negative right here. The quadratic formula gives us the x-intercepts by using the opposite of b plus or minus the square root of b squared minus 4ac, that entire quantity, divided by 2 times a. And we know that the a and the b and the c are the coefficients in standard form. In a quadratic equation of this form, standard form, the value of the expression b squared minus 4ac is known as the discriminant. This value is very helpful in determining the types of roots that we'll have in our quadratic equation. Discriminant. When the discriminant is a positive number, you will see two real solutions. When the discriminant is negative, you get no real solutions. They'll be imaginary or complex solutions. No real solutions. And when the discriminant is 0, you get one real solution. The input values of the x or x coordinate for each of the output values or y coordinate is 0. We said last lesson that's commonly called a root of the quadratic. So let's look at the first one, x squared plus 4x minus 3. If we want to know the solutions using the quadratic formula, the opposite of b is 4, a is 1, b is 4, c is negative 3. So using the quadratic formula, opposite b plus or minus the square root of b squared minus 4 times a times c, that entire quantity, all divided by 2 times a. Simplifying, we've got negative 4 plus or minus the square root of 16 plus 12 divided by 2. And 16 plus 12 is 28, and I'm going to rewrite 28 so that I can see 4 times 7, since 4 is a perfect square. So when we take negative 4 plus or minus 2 square roots of 7 divided by 2, we can simplify between the plus and minus sign as long as this 2 in the denominator divides both the 4 and the 2. So we can take out a negative 2 here and a plus or minus 1 here. That gives us our two solutions, negative 2 plus the square root of 7 divided by 1, and negative 2 minus the square root of 7 divided by 1. So we're just going to write the two solutions that way. I'm not going to give the decimal approximation. In example 2, we can't use quadratic formula excuse me, until we take the 4 over to the other side and set the equation equal to 0. Now, x is the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Now, do you notice our discriminant here is going to turn out to be 0? We've got the square root of 0. That means we're going to have one real solution, like we saw in the sample above. 16 minus 16, all divided by 2. So negative 4 plus or minus the square root of 0 divided by 2 is just going to produce one real solution, negative 2. That tells us that the parabola is sitting on the point negative 2, 0 and does not cross the x-axis. Again, you notice example 3 is not in standard form, so we've got to put the equation in standard form, setting it equal to 0 before we can apply the formula. Positive x squared plus 6x minus 5 is standard form. So x is the opposite of b, plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Cleaning up under the radical, we've got negative 4 times negative 5, that's positive 20. So 36 plus 20 gives us 56, and we're dividing by 2. Now think about rewriting the 56. We want to rewrite that as a perfect square times something. So I know 8 times 7, but 8's not a perfect square. I can rewrite 8 as 4 times 2, and 8 times 7 gives us 4 times the square root of 14. So taking out the square root, we have x is opposite 6 plus or minus the square root of 4, that's 2, times the square root of 14 divided by 2. Now, can we simplify between 6, 2, and 2? Yes. 2 divides negative 6 evenly. 2 divides 2 evenly. And our solutions to this quadratic will be negative 3 plus or minus the square root of 14. So 2 real solutions. In example 4, we're in standard form. The leading coefficient is the a value, so that's going to cause a little bit bigger denominator. Opposite b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And again, cleaning up underneath the radical sign, we have 24, 8 times 6, that's 48, plus 1 is 49 divided by 4. So 49 divided by 4. That's the square root of 49, gives us 7. So we have 2 different values to simplify. Either negative 1 plus 7 divided by 4, or negative 1 minus 7 divided by 4. This one turns out to be 6 divided by 4, so 1.5. And this one turns out to be negative 8 divided by 4, and that gives us negative 2. So 2 real solutions, since the discriminant was a perfect square, a positive number. So let's practice with the discriminant here in example 5. We know a is 2, b is negative 3, and c is 7. So we want to know the value of b squared minus 4ac. So 3 squared is 9. I think I'm just going to write 9. Minus 4 times 2 times 7. So this is, let's see, 8 times 7, that's 56. 9 minus 56, negative 47. And negative 47 is less than 0. That means we would expect no real solutions. And you can see the reason for that is because we can't take the square root of a negative number in the real number system. In B, we need to isolate a minus 6x minus 5. So standard form first, recognizing a is 1, b is negative 6, and c is negative 5. The value of the discriminant, b squared minus 4ac, is 36 minus 4 times 1 times negative 5. So 36 plus 20 is 56, and 56 is greater than 0. which means we would expect 2 real solutions in this case. In example C, A is 1, B is 13, and C is positive 4. So 13 squared is 169. 4 times 1 times 4 is 16. The difference would be 153. That's greater than 0. So again, C is just like B. We would know to receive 2 real solutions in this problem. And then lastly, x squared minus 6x plus 9. This looks like a perfect square. So b squared minus 4ac is 36 minus 4 times 1 times 9. And it is a perfect square trinomial. When we get 0 for the discriminant, that means there's only one real solution. The parabola is sitting on the x-axis at the 0. Now for this example, you're going to need your calculator. The equation d equals 120t minus 5t squared models the height of a fireworks charge on the 4th of July. T is measured in seconds and d is measured in meters. And we want to calculate the height after 3 seconds. So we're going to substitute 3 in the place of the 2 t's. So the distance is 120 times 3 minus 5 times 3 squared. So this distance is 360 minus 9 times 5, so that's 45. The distance is 315 meters in the air. So close to 1,000 feet. When will the rocket reach 450 meters? That means we want the distance 450 to equal the equation 120t minus 5t squared. So let's put the equation in standard form. 5t squared minus 120t plus 450. So divide through by 5 since each of the numbers are divisible by 5. And we find t squared minus 24t plus 90 equals 0. So here we can use the quadratic formula. And opposite b plus or minus the square root of b squared, that's 576, minus 4 times a, which is 4, times c, which is 90. So 4 times 1 times 90 is 360, divided by 2. And then very carefully figure out your numerator with the addition sign and divide that by 2. So I get 19.35 seconds. And then go back and figure out 24 minus the square root and divide that by 2. And that second answer is 4.65 seconds. So at about 5 seconds, it's at 450 feet. That would be on its way up. And then after it reaches a maximum and comes back down again at 19 1/3 seconds. When does it reach its highest point? Well, that's the time. And the time would be our x value, opposite b, divided by 2a. So the x coordinate of our parabola, so t is opposite b, and b was 120, so opposite b divided by 2 times a, and I'm taking this off the original so we get the right time, and 120, 2 into 60, or 10 divided into 120 would be at 12 seconds. So in 12 seconds, the fireworks charge is at a maximum. Then finally for part D, what is the highest distance reached? And that would be substituting back into our function for the 12 seconds we got here in part C. So the distance at 12 seconds is 120 times 12 minus 5 times 12 squared. So I'm going to get that with the calculator. 120 times 12 minus 5 times 144. And we see that the maximum height occurs at 720 meters. And then example C7 says we have the weekly revenue for a company is R equals 3p squared, negative 3p squared plus 62p plus 1080. And P is the price of the company's product. If we use the discriminant to find whether there's a price for which the weekly revenue would be $1,800. So let's think about that. So if we had $1,800 is the revenue at negative 3p squared plus 62p plus 1080, and we got that into standard form, then 0 would be here. Negative 3p squared plus 62p minus 720 would be standard form. And we're looking at b squared minus 4ac, so we want to know that value. And b squared is 62 squared minus 4 times a times c. And that turns out to be negative 4,796. So when this value is less than 0, then there are no real solutions because the discriminant is negative. We have the discriminant is negative, so we cannot have a revenue that would be $1,800. No revenue for this company. $1,800. And then our last example says that your club is selling boxes of cookie mix as a fundraiser. The total profit, P, depends on the amount, X, that your club charges for each box of cookie mix. The equation P is negative 1/2 x squared plus 30x minus 120 models the profit of the fundraiser. What's the smallest amount of dollars that you can charge and make a profit of at least $150? So we're thinking about writing the equation first of all, and 150 is equal to negative 1/2 x squared plus 30x minus 120. So I'm putting everything on the left side, 1/2 of an x squared minus 30x, and then add 120 to 150, we have 270, and that equals 0. So our A value is 1/2, our B value is negative 30, and our C value is 270. So again, we're going to need the calculator. Using the quadratic formula, X is the opposite of B plus or minus the square root of B squared minus 4 times A times C. That entire amount divided by 2 times A. And A was 1/2. Whoop, messing that up. A is 1/2. So with our calculator, the discriminant, this part under here, is going to be 360, and the denominator is 1. So we either have 30 plus the square root of 360, Or we have 30 minus the square root of 360. So calculating 30 plus the square root of 360, I get about 48.97, or 30 minus the square root of 360 is about 1103, and this is in dollars, so we want the amount, the smallest amount we can charge. So $11.03 is the smallest amount we can charge for a $150 profit. So $11.03. That's an expensive box of cookies. That's the smallest amount to charge for a $150 profit on the fundraiser. That finishes lesson 7 in chapter 4.